over the x-axis, how did we do it? Keep the x's and multiply by -1. For the y-axis, keep the y's, change the x by -1. And that line y equals x. Switch them, okay? So today we do translations. What's a translation? If you translate a figure, what do you do to it? Move it. Perfect. So you're basically going to slide or move it in any direction or a combination of directions. So basically what we're going to look at is they're going to give us a point, and we would call that point obviously xy. Now obviously there could be several points because it could be a triangle or a pentagon or whatever it is. And we're going to then be given, so we're going to move point xy by an ordered pair. And that ordered pair they're going to represent as AB. So essentially what happens here is whatever A is, I'm thinking about always adding it to my value of x. So obviously we could subtract if it was negative, but I'm always thinking about adding it. So my new point then would be x plus A and y plus B. And so then we could have a combination. So obviously we're going to do this to every single coordinate of the problem. All right? And then whatever it ends up being is what our answer is. And essentially, a lot of the times, instead of giving this what they call a vector, this would be a vector, how much you move something is, they'll a lot of the times give it to you as something kind of like this. So if you see those kind of parentheses, it means the exact same thing. It's just a different way of writing it. And don't freak out about it. It is the exact same thing. Again, you don't have to graph these. You just have to do the vertices like we did yesterday. All right? And then the last thing in this section, they try to have you do it showing your words, basically. So instead of looking at the problem and figuring it out, you would just tell everybody what you're going to do to move it. And again, we'll show you that in just a second. But essentially, that's all you have to do for today, is move whatever your figure is by this vector. Okay? Seems pretty easy, right? So let's try it out. So here's my first example. Obviously, they give me a graph of TUV, and they say to move this along the vector of -3, 2. So again, notice those parentheses that look a little like kind of arrows. So essentially, I'm going to move everything. And again, I'm always thinking about adding, but obviously if I have a positive and a negative, then I just subtract them. Okay? So again, we're going to represent it just like we represented it yesterday. So when I go to my next image, right, this is my pre-image. When I go to my image to draw it, I would call it not T, but what? T prime, put that little apostrophe, right? So what is T prime if I start out at -1, -4, and I'm going to apply -3, 2 to it? What would my X value of T prime be? -4. What would my Y be? -2. Again, remember, I'm just adding those together. So here we had a negative and a positive. So essentially we subtract them, but we're adding them together. How about you? 3 and 3, 4. Right? 3, 4 would be U prime. What's V prime? 2 and 2, -3. So again, we show all this. Went too fast. And there's my green one. So all I'm doing then is moving it. So I translated it. So realistically, I translated it to the left and up. But essentially it just looks like it went at a diagonal. And that's what a translation essentially is. Make sense? Pretty simple, right? Told you this chapter was easy. And this one, these vector ones are kind of a little harder, but I just want to show this to you. If you honestly wanted to be like a pilot, you would get very involved into vectors, okay? Especially like if you wanted to be a fighter pilot, you would really know a lot about vectors. But basically, these are kind of hard, especially with these teardrops, because you don't really know where the teardrop or raindrop or whatever it is actually is. So they say it's at 3.5, but then they're just showing you. So it says, describe the translation of the raindrop from position 2 to position 3. So if this is from 2 to 3, how did I get from 1, 2 to -1, -1? What would I have done? I did what? I added another 1, 2?
Well, to get -1, you had to add 1, 2 to the previous, or the
But if I add 1, 2 to 1, 2, I get 2, 4. Remember, I'm going the other way. So I'm going from 2 to 3. So what would I have to do to 1 to get to -1? What would I have to do to a 1 to get -1? I'd have to subtract 2, right? So essentially, my vector would show what? A -2 or a -2. And what would I have to do to 2 to get to -1? Subtract 3. So my vector essentially would be -2, -3. Or you would say it's going what? What does -2 as the x actually represent? It moving what direction? X. To the left 2, and then it would go what? Down 3 if we use that vector -2, -3. So essentially you could say vector -2, comma -3, or you could simply say we moved it left 2 and down 3. You understand what I'm saying there? So that's all they're trying to show you in those kind of problems right there. They just want you to show what you're doing to each problem. So there's your -2 and -3, and that's what. So they show it like this instead of, but basically I'm taking x -2 and I'm taking y -3. So that's, if you have to do one of those, I can't remember if you have to do it that way. But essentially, if you didn't write it out like this and you said you're just going, we're moving everything left 2 and down 3, I'd accept that too. Make sense? Okay? That's it. That's all you got to do for this section. Piece of cake, right? Again, you do not have to graph them. If you want to graph them, but you don't have to.